Welcome to Week 3 Non-Destructive Modeling. Non-destructive modeling refers to parametric modeling, which is modeling with parameters or attributes, and that's most of what we have done so far. Modeling with primitive objects, parametric splines, deformers, all of that falls under non-destructive because you're not directly editing the object's points or lines. Instead, you're using calculations that are happening using math formulas based on the parameters that you input. The benefits of this is that you can always snap back to the original shape, regardless of how many alterations you have made to it. However, after this presentation, we are going to begin destroying things. You did get a peek at this destruction when we discussed editable splines and the pen tool. If you remember, you can alter editable spline points directly, and this means that you are destroying the spline. The benefit of this is the amount of freedom that you have, because now you're the captain and you have control over every single part of your object. But the downside of this is that there's no simple snapback. Today we're going to cover a few new generators that do not generate their own geometry, so they require objects as their children to work. First, let's talk about the Boolean generator. The Boolean generator creates Boolean operations on objects. It makes two of its child objects or more interact with one another based on their position within the Boolean and the type of operation. You remember the spline mask? The Boolean generator works similar, but instead of spline, it affects objects. There are 4 types of Boolean operations which you can alter in the attributes of the Boolean. I put materials on these objects to show you the difference when I use the Boolean. First, union combines both objects. In this case, the inner part of the sphere is being cut off. Subtract removes every other object from the first child, in this case the cube. The order here is very important as things will get subtracted only from the first child. Intersect shows only the portions of the objects that are overlapping with one another and removes everything else. Lastly, without is similar to subtract, but it does not leave behind parts of the object that intersect. Therefore, there is a hole in the mesh. New vocabulary word, mesh. Mesh is the structural build of a 3-dimensional model consisting of polygons. We will discuss this more in depth next week. The symmetry generator creates a mirror of its child object. Anything that you do to the child will also affect the symmetrical object. For now, we're only going to be using the symmetry object to create duplicate objects like eyes, but later on, we're going to learn how it can be used to create things like a symmetrical face. Let's make a sphere a child of a symmetry. The symmetry generator works based on what mirror you use and where your object is originally located. Right now, it looks like nothing happened, but the reason is that your symmetry creates a mirror starting from 0, 0, 0. So if we move the sphere over, there we go. Notice how the symmetry sphere does everything that the original does, but mirrored. By default, the mirror plane is X plus to minus. Plus to minus or minus to plus just means that it's turned on, whereas off means that it's turned off. This means that it is mirroring across your x-axis. So think about this red plane here that is showing up as a mirror. The reason you can see this here is because of this show planes option right here. You can mirror in any of the other planes. For example, I can turn off my X here, and instead I want to mirror in Y. I would move my sphere a little out of the way, and you see that now the mirror is happening in Y, meaning up and down. Again, turn on my X. And now one sphere has turned into 4 different spheres, all symmetrical to the original, which is this one on the top right. And let's not forget Z. Once again, I need to move the sphere out of the exact middle of the plane because otherwise it is just creating the copy right on top of it. Once you're done using the symmetry object, make sure to turn off show planes, so that you don't have all of those colors there in the middle and your viewport's a little easier to see. You can also change the type of symmetry generator that is happening. Change the type from planar to radial. Now these are all being symmetrical in the x-axis, and you can change how many there are. Back to planar. We are going to cover some of the other options later on. For example, weld, which is very important when it comes to creating a symmetrical face or half of a body or something like that. Just be aware that it exists right here. Now we have the connect object, which connects objects together. It also has the ability to weld primitive objects. The way that this works is that it looks at where the points of your objects are at and connects them together based on what tolerance you give it. So let's take out two plane objects to test this out. I will move one of them to the left and rotate it slightly. Now let's make them both children of the connect object. Now it may seem like nothing happened, and that is because right now all we're telling the connect object is that it has these two objects as children of it, but it's not going to connect them because the tolerance is set to 0.1 centimeter. If these points here and these points here were 0.1 centimeters away from each other, they would be connected. Because they are not being connected. The only thing that did happen is that now Cinema is considering both of these planes as one object. So for example, if I were to use a Boolean now, I had to do a few things to try to show you this visual. So if you try this out, it's not going to go exactly like mine is, but I just want to show you that the Boolean is considering that the connect is getting the cube cut out of it. Now, without adding anything else, let's talk about tolerance. So again, because these are not 0.1 centimeters away from each other, they are not going to connect. But if I increase this, eventually I reach the threshold that was in between these two planes, and now they are turned into one object connected by what is fake geometry. So this is happening at 10.68. So that means that between these two planes, they're 10.68 centimeters. And because I am telling the tolerance of my connect that if it is anything below that I want it to connect, it will connect both of these. Anything above that, for example, if I were to move this, now they are disconnected because now it's more than 10.68. Now let's talk about the volume builder and the volume mesher. The volume builder creates voxels, which are 3D pixels, using Cinema 4D objects. You can combine these voxels and do Boolean operations on them, and its partner, the volume mesher, takes those voxels and transforms them back into geometry. The volume builder is incredible, and you can think of it as like an enhanced version of the Boolean generator, but it definitely comes at a cost. As soon as you begin adding a lot of objects to the builder, or you try to make the voxel size very small so that you get nice details, it can significantly slow down your machine, especially when you turn the voxels back into geometry. First, take out the volume builder by either clicking once here or opening the menu and selecting volume builder. Then take out a cube, a sphere, and a cylinder. Make all of them children of the volume builder. And let's position the sphere and the cylinder around the cube. The voxel size is how big your individual 3D pixels are. This is very important when it comes to how sharp your geometry is. The smaller the number, the more voxels are needed. And this is going to make your object look a lot sharper. However, notice that if I go too low, I start to get a warning that the voxel size is going to cause a long calculation time. What does this mean? It will probably crash Cinema. Do not go below 0.01 as it will very likely crash your Cinema 4D. The smaller the size of your voxels, the more processing power it takes from your computer. Next, you have the objects box. This is where the children of the volume builder live in. So here is where you can determine the order of your objects and what Boolean operation occurs. By default, they are set to union, but similar to the Boolean generator, you can change that to subtract or intersect. Notice that the order here works like layers, so things will affect whatever is underneath it. For example, if I set my sphere to union and then my cylinder to subtract and move it to affect both the sphere and the cube, it will affect both. But even if here I don't change the order, but I change the order here, now the cylinder is only subtracting from the cube and the sphere is adding to both of them. Look here, if the cylinder, again, I haven't changed anything in the objects manager, this is where the order matters. I just set it so that the sphere is union to the cube and the cylinder, but the cube is set to intersect with the cylinder. So only the things that are intersecting between these two are going to show up. And then here is going to add on to whatever is left after that intersection. So please pay attention that the order really, really matters. At the bottom here, you can see something called the SDF Smooth. This is a filter that allows you to smooth out your objects. There are a few others. We're only going to be using the SDF Smooth. And this, for example, if you select it, again, the order matters. Because it is above, it is smoothing everything out. And how much? 100% based on the strength. You can change this. Again, order matters. If I just make this SDF be between the cylinder and the sphere, now it's only smoothing out the cylinder and cube. It is not smoothing out the sphere. You can also have folders which dictate sub-portions that are going to be affected together. Now, when you are done dealing with your volume builder, be aware that they do not render anything. The volume builder by itself does not render it because Cinema does not recognize voxels. So you need to turn this back into geometry. To do that, you need the volume mesher. Remember the vocabulary word from earlier, mesh. We need to turn this back into a 3D mesh. So take the volume builder, make it a child of the volume mesher, and now this is back to being geometry, and now you can render it.